Hello and welcome to last option. This is the solution video of next 5 questions. In the first question, which we can call it as the concept of distance appearancy, because distance is not what actually it is. It depends on the observer's positions. So in order to understand in a better way, let's move to this, and this is also present in the description box where link is given. You can go there and see and you can analyze what are the different parameters that are taken into this one. It's not a complete one because distance appearancy concept will keep on repeating. If we consider a small segment, it will keep on repeating, but at some location we must end. So that's the thing we have considered here. Even though if you are not satisfied with this solution, you can go on, but it will never end because we are going to consider a small segment, and that small segment is going to be divided into the segments, so it would never end. So let's see this. So let's consider that observer is observing this rod AK from point O. So the apparent length with which the observer is going to observe this whole length is AB, and it depends on the angle of theta and one more angle alpha. We have considered OA equal to A, and other parameters are also given. So with the help of basic mathematics that we have practiced till now, we would be able to come to the conclusion using the triangles, different triangles, and for more precise calculation we have also used the triangle concept over this point also, where it was not needed but we applied it. So the overall length with which the observer is going to observe is AB. Here we have considered other parameters also. So the final length with which this small segment DE is going to appear is given by this formula. So it has not been calculated for the whole length, but it can be considered for an whole length. In actual state it's not possible to find the whole length, because once again we have to apply this concept of distance appearancy to this distance DE also, and it will keep on continuing. But we have to end this one, so we have only considered to a small values only. Let's on move to the question number 2. Question number 2 was related to black hole, and in black hole we are given as its mass is m, its radius is r, and light is circulating around the black hole, which in general is called as accretion disk, and its radius is small r. So we were asked different parameters. One thing which is important to consider is the particle nature of light, because as it is attracting towards a black hole, so it must have a mass, because it's only due to the gravitational attraction of this one. Hence from the Newton law it must have mass, because gravitational force only exists between the bodies which are having masses, as electric force exists only between the bodies having electric charge. So here masses must be considered. So let's consider is mass equal to m, small m. So one outward force would be there and one inward force due to gravitation would be there. So now it's just a simple case. Therefore gravitational force, that is force inward, is equal to force outward. What's the force inward? That's important. G capital M small m upon distance r square, small r square, that is equal to force outward, that is centripetal force that body experience when it's move around it. You would have experienced, listen to it. What's that? M is mass into its velocity upon distance from the center, r, which in turn turn out to be Gm small m upon r equal to mv square. I am not cancel this small m for one particular reason, because I have to correlate this wavelength with this equation, so I must consider momentum, because if there is a wave, there is a particle nature also. We use de Broglie concept. That's a linkage between the mass nature and the particle nature of the wave. Okay, so what I can do is multiply and divide by 2. Now this term is kinetic energy. Now kinetic energy equal to 2p square upon 2m, which in turn turn out to be cancelled. Therefore, p square equal to m this side, gm small m square upon r. What is this p? P is momentum. Momentum equal to h upon lambda, h square upon lambda square. Hence, from here you will get lambda as root over h square r upon g capital N small n square. So this is the relation. Now if I would ask you, if I am having a red light, let's take it. If I am having a red light and one blue light, which would be more closer towards the black hole, red or black? Here you would be able to find it. Lambda is directly proportional to r. So means greater the lambda value, greater is the small r value. Hence red would be circulating outward and blue would be towards the black hole, that is more closer to the black hole. That is the reason why you in the picture of black hole you find red color around the corner, whereas as you keep on going inside it turned out to be yellow. So that is the fundamental reason behind why is this happening so. So this is an important one, nothing special, just a basic concept, a basic idea of Newton's one, that is body having masses can only attract each other. And this is question number 3. Question number 3 says that fn of x is 0 when x is less than 1 by 2n and when x is in between 1 by 2n, and 0 when x is greater than 1 by 2n. So we will need to find this value. One thing is the normal method which you can go by conventional way. The other thing is the smarter way. Let's check. Let's draw the graph of fn of x. Here x and its output, well let it be y. So here 1 by 2n, here minus of 1 by 2n. So its value is n here, and for other value it's 0. So what you can say about it? It's even function, and this sin x you can directly say it's odd function, where we have to integrate minus infinity to infinity. What does this give? It gives the area under the curve between what? Fn of x and sin of x, their multiplication. So if one is even function, other is odd function, their product is going to be odd function. That means their graph would be like this one, not the same but somewhat like this. Hence its total value would be 0, as one would be giving positive area, other is giving negative area. Here area is not modulus is given, so we have to take with the sign one. Hence its value is equal to 0. Easier one. Other thing is you can just put out these values, and this minus infinity to infinity needs to be divided. That's minus infinity to minus 1 by 2n, 1 by minus 1 by 2n to 2n, and then 1 by 2n to infinity. By that you can go. Question number 4. Question number 4 is directly from Fourier series. So recalling the Fourier series, f of x, that is any function, can be written down into a periodic function. And let me tell you, this is having a very significant important in the development of quantum mechanics. So this is nothing but a naught by 2 plus summation of k equal to 1 to infinity. What's this one? A of k into cos of kx plus a of k into sine of kx. This is the general form of Fourier series. So comparing these two, it's going to give a odd function. In odd function we get only this much of term. whereas this and the cos term is going to be cancelled out. Hence here f of x equal to x. Hence a of k is equal to, what's this one? We can write it as 2 by L. What is L? In between the range, where k was given from minus pi to pi. So this can be written as from 0 to pi, as it is going to odd function, and f of x into sine of kx dx. This is going to give a coefficient of this term, and we were asked a of 2. So here by simply putting k equal to 2, we can get this much of value, where f of x equal to x by comparing these two. So with this one directly you will get value as minus of pi. So any type of objective can be made using this one. So the main thing is, it's from a Fourier series, it's odd function, it's general term, and then comparing and then putting this value. I could have asked you what the value of a of 100. Simply you would have put 100 here. Directly you can get. This is question number 5. Question number 5 is a brilliant and a classical example of Faraday work over electromagnetic induction. In the question we were given that we are having one loop and a lambda is given. That means we are having a EM plane wave, and we were asked to find what should be the area angle between the area vector and its propagation so as to get a maximum EMF. From the concept of Faraday, maximum EMF would be induced if there is maximum flux change that is going to link with the loop, and this in turn can be written as A into dB by dt. So EMF directly related to the magnetic field. One more thing, this can again be changed into A into minus dE by dx. What the hell is this? This is the law of Maxwell. With the help of this conversion, he was able to find the speed of light in a vacuum. So this holds an important result. However, it's not going to change a lot to this question, but it changes a lot in the field of physics. So again, taking this one, we are having lambda, its area vector. So if I am having an EM wave traveling along this way, so this could be the direction of electric field and this would be the direction of magnetic field. So hence, whenever magnetic field linkage is there would be change like this one. So I need to develop a potential difference across these two ends in order to extract the current and measure it. Hence, maximum EMF is to be induced, maximum difference of EMF is to be induced in between these two ends. So as there is a change in the magnetic field, the magnitude of magnetic field, there would be an induction of EMF along this end. Hence, it should travel in this way. What's the case when this one? Try it out. So the answer is the angle should be 90 degree in order to get the maximum EMF generated. So this is all about the solution of next 5 questions. We will be back with the next 5 questions. Thank you.